Let's talk about note card 14, function arithmetic. We're going to be adding functions, subtracting functions, multiplying functions, and dividing functions. Okay? When I say f plus g of x, what this means is f of x plus g of x. When I say, or when you see rather, f minus g of x, that means f of x minus g of x. When you see f times g of x, that means f of x times g of x. And then finally, when you see f divided by g of x, that means f of x divided by g of x. So let's try some of these out. We have f of x is equal to x plus 2, and we have g of x is equal to x squared minus 3x minus 10. So let's try these operations. Example A, we're going to do f plus g of x. That means we're going to do f of x plus g of x. So if I have f of x is x plus 2 plus g of x is x squared minus 3x minus 10, we're simply going to combine like terms and see if we can factor at the end. So here I have, when I combine like terms, x squared minus 2x minus 8. Because we have an x squared, that's gone. Then I have an x and a minus 3x. And when you combine those together, x minus 3x is minus 2x. And then I have a 2 minus 10. When I combine those, I get minus 8. Let's see if this is factorable. This is minus, so my signs are going to be different. This tells me my biggest sign is going to be negative. A is 1. B is negative 2. C is negative 8. My next step is to multiply A times C, and I'll do it up here, give myself some room. A times C is negative 8. You can forget about this negative sign for now, because our signs in our factored answer are taken care of right here when I identified at the beginning that the biggest one, or they're going to be different signs, and the biggest one's going to be negative. So I have minus 8. So the next step is to list the factors of just 8, or the two numbers that I multiply together to get 8, and that's going to be 8 and 1, 4 and 2. My signs are different, and the biggest one is negative, so that means these two big ones are negative. Which two sets of numbers, or which set of numbers, adds to get to negative 2? And it's these two. It's these two. And so the next step is to divide by A, which is 1. So I divide by 1. And finally, my last step, and the easiest step of all, is x goes with the number on bottom. So I have a 1x minus 4, or just x minus 4. And I have a 1x plus 2, or just x plus 2. And this is my factored answer. It is the answer that I prefer. However, you need to be able to recognize on a test. Some of our tests are multiple choice. So you need to be able to recognize if your answer choice is in this form or in this form. They are equivalent. You need to be able to tell the difference, or tell that they're the same. Example B, we're going to do f minus g of x, or f of x minus g of x. And f of x again is x plus 2, I believe. Let me check. x plus 2, and I want to subtract g of x. Now pay attention really close right here what I'm about to show you. G of x right now is just this one term g of x. But g of x is about to become these three terms right here. And so what I need to do when I'm subtracting, I need to open up a set of parentheses because this negative 1 is going to have to be distributed to all three of those terms. So I'll distribute and combine like terms. So I have x plus 2 minus x squared plus 3x plus 10. Combine my like terms. I've got 1 x squared. That's a negative x squared. That's gone. I'll cross it out. Now look at my x's. I have an x plus 3x. That's plus 4x. Those are gone, and I'll cancel those out. Then I have a 2 plus 10, which is plus 12. So now I need to factor. Something that we haven't talked about in pre-cal this year is if you have a negative in front of any polynomial that you're going to factor, you want to factor that out first. So if I factor out a negative 1, that leaves me with x squared minus 4x minus 12. All I've done was pull out a negative 1, which essentially means I divided each term by negative 1, so I've changed my signs. Continuing to factor. I think my battery's getting low on my pen. My signs are going to be different, and the biggest one is going to be negative. A is 1, B is negative 4, C is negative 12. Next step is A times C. That's what I was trying to do, change my color. So A times C is negative 12, and again, I'm not worried about this negative sign right now. List my factors. 12 times 1, 6 times 2, and 4 times 3. Okay, so here's my factors. And so my signs are different. The biggest one is negative, so I get a negative 12, negative 6, negative 4. And I'm looking, does any of the sets add to negative 4? And the answer is yes, these two. So I have negative 6 and 2 are my factors that I'm using. Next step is to divide by A. And then finally, does it reduce? No, these fractions do not reduce, so x goes with the number on bottom. And so that's going to be x minus 6 and x plus 2. And this is my answer. Oh, and do not forget that minus 1 you pulled out at front. It's got to go right with the answer. Now for C, we're going to do f times g of x, which is f of x times g of x. And so f of x is x plus 2. And g of x, I'm going to be multiplying, so I'm going to put these in parentheses. And g of x was x squared minus 3x minus 10. Now, we could distribute the first term to here, and the first term to here, and the first term to here, and then the second to here, the second to here, and the second to here. And it's kind of a modified FOIL, and if you want to do that, you're welcome to do it. However, I recommend when you're multiplying two polynomials together and one of them is bigger than a binomial, which means it has more than two terms in it, I'd recommend the box method. And so I need a 2 by 3 box because I have 2 terms by 3 terms. So So I need to make a 2 by 3 box. And so on this side, on the 2 side, I've got an x plus 2. And then up here I have x squared minus 3x minus 10. Notice that when I have negatives or minuses, I put it in front because that sign goes with that number. Over here I didn't have to put the plus 2 because it's positive. It's not necessary. I could if I wanted to, but not necessary. Now I multiply the appropriate boxes. X times x squared is x to the third. X times minus 3x is minus 3x squared, just like a Punnett square. X times minus 10 is minus 10x. 2 times x squared is 2x squared. 2 times minus 3x is minus 6x. And 2 times minus 10 is minus 20. Now when you use the box method, notice that your like terms are in diagonal columns, which makes it pretty easy to combine. So I have an x to the third. Then I have 2x squared minus 3x squared, which is minus x squared. Then I have a minus 6x minus 10x, which is minus 16x. And then I have a minus 20. We haven't talked about factoring cubics. I do not have any like terms, so this is my answer. I could have used grouping up here and grouped these two together. I'm not going to do that right now, but I'll show you what I'm talking about quickly. I could have paired these two together and then these two together, and I could have taken out a common factor and factored it that way. But since we haven't really been talking about that so far this year, I'll leave that be. Okay, D, f divided by g of x means I'm going to do f of x divided by g of x. And so what we have is f of x, which is x plus 2, divided by g of x, which was x squared minus 3x minus 10. And so I want to, nothing cancels from top to bottom. There's no like terms to combine. So I'm going to try to factor the bottom to see if maybe something, I can get a factor on bottom that matches the factor on top, and those two can cancel. So my signs are going to be different. My biggest one's going to be negative. And so I will have A is 1, B is negative 3, and C is negative 10. A times C is negative 10. So I need to look at my factors of 10. Remember, I'm not worried about this negative sign when I multiply A times C together because my signs are taken care of up here. So I've got 10 times 1 and 5 times 2. My biggest one is negative, so does either pair add to get to negative 3? And the answer is yes. These two. My next step is to divide by A, which is 1. And then finally x goes with the number on bottom. So that'll be x minus 5 times x plus 2. And remember, that was just my denominator. So this is the denominator of this fraction. And notice that these two factors match. Since they match, they cancel. So what I'm left with, since all of x plus 2 goes away, I have to replace that with a 1, because x, basically what I have here, a little side note is, x plus 2 over x plus 2 is just 1, or 1 over 1. So I get 1 up top over what's left over was x minus 5. And that's my answer. Now, quickly let's go back to the previous example because I just feel like I need to go ahead and show you how this factoring works. I know you've seen it, but a quick review. If you have 4 terms and not all 4 terms have a common factor, if you can group them so that you get a common term in each group that you can factor out, we can do it that way. Sometimes it doesn't matter how you group them, sometimes it does. Here I'm just going to try to put the first 2 together and the second 2 together. So in the first term here I have a common factor of x squared So I'd pull an x squared out, and what I get left is x minus 1. And this one's not going to factor, I don't think. So here I'm going to do, in this group, I have a common factor of minus 4. So I'd pull out a minus 4. And when I divide these by minus 4 here, I get 4x minus 5, or plus 5 rather. And here's the problem. The problem is that in order for this type of factoring to work, what you get in the parentheses here must match what you get in parentheses here. If you don't, then you've got a problem. What you would normally do is go back to the original. If these two don't match, I would want to go back to the original problem and see if there's another way that I can group them that it would work out. Well, if I grouped the x squared with the 16x, then I would have an x to take out, and that would work. But if I did that, then if I group those two together, then I'm left with grouping the x to the third with the minus 20, and I wouldn't have a common term to take out. So in short, that was kind of a review of how to do it, even though it doesn't factor regardless. This would have been your answer. It would not factor. But in the future, if you have 4 terms like that, try the grouping and see if that works.